a media project brought to you by Aidan Perry. The word particle originates from the Latin word particula, meaning little part, and that is exactly what it is. In very simple terms, it is a little part of something. In science, we define particle as a little portion of matter. These little particles make up literally everything in the universe. Even the air we breathe is made up of particles. Solids have a fixed shape and volume. They are rigid and have little space between particles. They do not flow and the particles cannot slide or move past each other. This is because the particles are tightly packed in a recurring pattern, although they do vibrate on the spot. Liquids takes the shape of its container whilst maintaining its volume. They are not easily compressed and have little space between particles, but enough so they can slide past each other. Hence, liquids have the ability to flow. The particles of a liquid have no consistent pattern. Gases take the shape of its container and also the volume of its container. They can be easily compressed and have lots of space between particles. Because of this, they can flow easily. The particles of a gas have an irregular and inconsistent pattern. Furthermore, they move freely at fast speeds. Plasma is usually very hot. This is because a very high temperature is required to break the bonds between electrons and the nuclei of the atoms. The way plasma is created is through adding energy to a gas so that most of its electrons leave its atoms. This process is called ionization. It results in negatively charged electrons and positively charged ions. Unlike solids, liquids, and gases, the charged particles in a plasma will react strongly to electric and magnetic fields, for example, electromagnetic fields. Because electrons and ions have electric charges, they are pulled together or pushed apart by electric fields and magnetic fields. This makes plasma act differently to gases. An example of plasma on Earth is lightning. A common rookie mistake when learning about particles is thinking that evaporation and boiling are one and the same, when they really aren't. Let me spill the facts. Evaporation takes place at any temperature above the freezing point and below the boiling point. It is a slow process where a compound turns into a gas over time and can take place using its own internal energy. It occurs at the surface and speeds up when there is more heat. Boiling occurs when the temperature of the liquid reaches or surpasses the temperature of its boiling point. It is the phase transition from liquid to gas, and it occurs below the surface. It is a rapid process, unlike in evaporation, where it is gradual. Melting is the change of state from solid to liquid. For example, when chocolate melts because Jakarta is way too hot. Freezing is the change of state from liquid to solid. For example, when you freeze water in cube slots to make ice cubes. Vaporization is the change of state from liquid to gas. For example, when you boil water before cooking indomie and water vapor is produced. Condensation is the change of state from gas to liquid. For example, when there are water droplets on the outside of your glass of iced water. Sublimation is the change of state from solid to gas. For example, when dry ice is formed. Deposition is the change of state from gas to solid. For example, when water vapor turns directly into ice in clouds, which is then known as snow. The Brownian motion is a phenomenon which occurs in fluids such as liquids and gases, and it is when particles move randomly due to collision it undergoes with atoms, molecules, and other particles. Thermal expansion is when a substance changes in size because of a change in temperature. Some materials will expand more than others. An example of this is evident with metals. They expand because of the movement of molecules caused by an addition of thermal energy. The manipulation of hardware through thermal expansion is used every day. This can be seen in thermostats. A common type of thermostat is the bimetallic strip. Two metals with different expansion coefficients or expansion percentage for a given amount of heat are bonded. When heat is applied, the strip bends. This can close or open a contract. These types of thermostats are used in home heating and air conditioning systems and on electric stove burners and ovens. Also, jet engines leak fuel at normal temperatures. Once they fire up, the metal expands and the leaking stops. The Concorde supersonic jet was actually engineered to grow about 18 inches due to thermal expansion in the flight. Boyle's law states that the volume of a fixed mass of gas at a constant temperature is directly proportional to the pressure. When a gas is pumped into an enclosed space, it will shrink to fit into that space, increasing the pressure put on the gas. Boyle's law is the relationship between pressure and volume. Mathematically, Boyle's law can be written as PV equals K, where P is the pressure of the gas, V is the volume of the gas, and K is a constant. An example of Boyle's law in action can be seen in a balloon. Air is blown into the balloon. The pressure of that air pushes on the rubber, making the balloon expand. If one end of the balloon is squeezed, making the volume smaller, the pressure inside increases, making the unsqueezed part of the balloon expand. There is a limit to how much the air or gas can be compressed, however, because eventually the pressure becomes so great it pops the balloon. Charles's law states that the volume for a mixed mass of gas at constant pressure is directly proportional to the Kelvin temperature. If pressure remains constant, the volume of a mass of gas is proportional to its absolute temperature. The absolute temperature is always 273 Kelvin more than the centigrade temperature. An illustration that is helpful for understanding Charles's law is when you have the same amount of molecules in two separate volumes, yet they displace different volumes because they are at two different temperatures. In the two separate volumes, there are the same amount of molecules, but because of the different temperatures, they have different volumes. A common application of Charles's law is seen in basketballs during cold weather. Throughout a cold day or night, a basketball may shrink in size quite noticeably because of it losing air. This means that a basketball shrinks during cold weather because of temperature decrease, which also decreases its volume. And that was The Particle Model by Aidan Perry. Thank you for watching.